Alright, so you guys should have already watched the ions ed puzzle to give you kind of a basic idea of ions in general, how they're formed, and how you can figure out what the charge of an individual ion is based on its valence electrons. The next thing we're going to talk about is how they bond with themselves or form compounds that are a little bit different from the ones we were doing last week. So last week, when you were looking at the Lewis dot structures, all of those compounds you were drawing, those were all covalent bonds. All right, what we're worried about this week are ionic bonds. All right, so but whether it's ionic or covalent, pretty much all chemical bonds want to follow what's called the octet rule, which is that atoms are most stable when they have 8 valence electrons in their outer shell, and they will make bonds with other atoms, either ionic or covalent, in order to get to that state and improve their stability. All right, the noble gases are kind of the exceptions because they already have 8 valence electrons, so they don't need to bond with anything. They're what's called non-reactive. That's why they were named the noble gases, because they like hold themselves apart from everything else. All right, so what we saw last week were covalent bonds. And so this is when two atoms want to share a pair of electrons between them. So typically these happen between two nonmetals, which are everything over on that right side of the periodic table. And so you can see here these bond lines like this where we drew, where each atom was giving up, each atom was giving up one electron to make this bonding pair. Those are all going to be covalent bonds. So everything we did last week, covalent bonds. Okay, what we're going to talk about today are ionic bonds. So ionic bonds occur when instead of sharing, the atom just takes the electron away from the other one. So you can see down here in the covalent bond, these two atoms each have a hold on both of these electrons. It's being shared between them. On the ionic bond side, this sodium just gives up that electron. It's gone. It doesn't have it in its ring at all anymore, and the chlorine gets an extra one to fill it out. All right, usually ionic bonds occur between a metal and a nonmetal. And then when the electrons are taken away, it changes the charges of both atoms. So when this sodium loses that electron, it becomes positively charged. And when the chlorine gains the electron, it becomes negatively charged overall. All right, and when that happens, when their charges change, because they now have opposite charges from each other, they're going to attract one another, like the opposite poles of a magnet. They pull each other closer. So that's what actually forms the bond between the two of them, is those negative charges attracting each other. All right, so what your homework today is going to be is actually figuring out what kind of compounds these would make when they bond with each other. All right, if you remember from that other video, I talked about cations and anions. So your cations are going to be your positive charges, or your positively charged ions. Typically that's the metal. And your anions are usually going to be your nonmetal. That's your negatively charged ions. That's what we've got over here. So what you want to do when you're trying to put these together and form a compound is to balance out the overall charge of the compound so that it is neutral. It has no charge. They cancel each other out. All right, so if we look at this first example here, where we've got aluminum plus 3 and chlorine minus, if there's no number after the minus or plus sign like you see on the sodium and the chlorine here, that just means it's a -1 or a +1 charge. All right, so we've got aluminum plus 3 and chlorine -1. So in order for our compound to overall be neutral and have no charge, we've got to have 3 of these chlorines so that they combine to make a total of -3 charge. The aluminum is +3, and they would balance each other out. Down here, it's kind of the opposite direction, where the sulfur is a -2 anion, and your cation is only +1, So you need 2 of them in order to balance out the sulfur. All right, so you can do this by just kind of common sensing it like that, or if you're trying to go quickly, the trick for that is whatever this charge number is up here becomes the subscript of the other ion. So this 3, you're going to move down to the subscript of the chlorine, and the 1 gets moved down to the subscript of the aluminum. So you end up with Al1 and Cl3, just like you have here. So that's another way you can do that. All right. So you guys are going to have a bunch of problems like this in your homework. These are much less time consuming than drawing out the covalent bond structures, because you don't have to worry about, well, is it double bonded or triple bonded or lone electron pairs or anything like that. These are just how many of each one do you need to make it balanced. That's all you're doing.